Today, I have the great honour of speaking to Claire Gormely, and Claire is full professor at the UCD School of Mathematics and Statistics. And we will chat about statistics, the key to unlocking the story in data. Hi, Claire. How are you today?
I'm good. Hi, Trisha. Good today. Thanks. Yeah, enjoying the good weather.
Exactly, same as myself. So, first question for you today, Claire, is where are you located and what's been keeping you going over the last few months?
So I'm located just a few miles from UCD campus, which I haven't unfortunately been in since last March. And what's been keeping me going, with a busy house here with myself and my husband both working from home and a few little kids running around keeping us busy. But our 5 kilometres includes the Dublin Mountains, so I try and get up into them for a run or a cycle, attempt some sanity. So that's been
And
keeping me going.
just to get outdoors, I understand you, Claire. So, Claire, you are full professor at the UCD School of Maths and Statistics. Can you please tell our audience about your role and what makes you so passionate about what you do?
Sure. So what I do is I lecture statistics, the discipline of statistics, to undergraduate and top postgraduate students. And I'm also a researcher, and I supervise PhD students and postdoctoral researchers in the field of statistics. Why I'm passionate about it is, well, I clearly love the science. It's what I do. It's mathematical, it's statistical, and it's interdisciplinary. But I also love the people side of our role. I really enjoy teaching. I enjoy the students. And particularly been really lucky to supervise excellent PhD students and seeing their sort of evolution into independent researchers and heading on to pastures new. It's a really rewarding and yeah, makes you passionate about your role.
Wonderful, Claire. So, moving on to your title, Statistics, the key to unlocking the story in data. Maybe you could tell our audience a bit more about this, please.
Sure. So statistics is the science of data, and that's what we do. But I suppose there's statistics, the noun, which are the numbers that we all see. But then there's statistics, which is the science and the discipline in which I'm involved. And our role there is to develop statistical tools and methods that are principled and rigorous, that are applicable to different data sets. And each data set is different in shape, in form, in scale. And there's a story within that, and that's what very often the interdisciplinary researcher wants to unlock or find out what's inside that data set. But no very few data sets are the same, so you very often need different and bespoke tools, like different keys to unlock that story within the data. So we use statistics and mathematics to develop those algorithms and those statistical methods to analyze the data sets.
Okay, and I suppose you've mentioned the word interdisciplinary, but as you know, in Discovery, we're very passionate about interdisciplinarity. So maybe how important is that to statistics?
It's fundamental. I suppose, like most disciplines, statistics is a full spectrum. So you have very theoretical statistics, that's very, proofs and theorems. Then you have, sort of what I call methodological statistics, which is mostly where my work is, where we develop statistical methods, right through to very applied research, where you apply existing statistical tools. But in that methodology piece, the development of statistical methodology, predominantly those methods are inspired or stimulated or come about from that interdisciplinary research, or from biology or social science or wherever, coming and saying, look, I have this data set and I can't find the right method to analyze it. You realize that there is no method to analyze that particular form of data, and then that motivates our development of the statistical method, of that key to unlock the story there. So it's great because it's interdisciplinary in that you're working with, whether it's a biologist, a geneticist, a historian, we literally work with everyone right across the humanities, social sciences and sciences. You're working with maths, statistics, computer programming, communication. It's very important in statistics to communicate your results and graphics and visualization. So it calls on a whole range of skills, and it is very often stimulated and enriched by that interdisciplinary collaborative kind of experience.
Okay, so lots of skills needed and also needed to tell the story in the end. So an interesting question coming in for you already is in terms of what you mean by the key to unlock. What is that? What is that?
So I suppose if you think about why we collect data, or if you take a the standard example of, let's say, a new drug has been brought into the market, and they want to know, well, is it safe? What's its efficacy? So we design a study, and the story we want to know is that drug, does it work? But the way we sort of measure that is through the data, and then the story of whether that drug works or not is within that data set. So you can't just look at a spreadsheet of data or a database and figure out what is in there. We have to use statistical methods to see, well, does the average blood pressure go up or down under this drug? So the story is hidden in that sort of language of data, and we're trying to translate it or unlock it.
Okay, and I should have said, actually, to the audience, don't forget to submit your questions. I know some of you already are, but please, there's lots coming in, actually, which is great. So actually, along those lines about methods and statistics, here's an interesting one. Are there still new methods in statistics being discovered? Can you describe how they are different than things like the student t-test or hypothesis testing?
Oh, absolutely. I suppose that's what, if you take the statistics research group in UCD, that's very much what we do is develop new statistical methods and discover them, if you want to use that word. And maybe that example is, the student's t-test is familiar to so many people, but that's for a very specific setting where, for example, you have two groups of patients or whatever it is, and you want to see, is there a difference in the means? But then take a data set from genetics that is, huge in terms of the number of things that are measured, and possibly huge in the number of observations. And a t-test doesn't work there. It's a key that won't work on that data set. So depending on the format of the data, whether it's, large, small, what the data look like, are they recorded over time? Are they categorical, or are they, spectral data? There's so many different varieties of data. If there is no existing method that works, then that is very much what statistics research does, is the development of those new methods.
Okay, and actually here's one. I nearly want to ask this myself. Many people, students and staff, get intimidated quickly by stats. Claire, what would you suggest are the best go-to texts for different areas of stats?
Good question. I think that the interesting piece about stats is, we all see those kind of, year or entry level statistics pieces that are about the t-test and so on, and you kind of learn off the tools. And the really interesting stuff comes after that, and it's when your data gets richer and more complex, and it's an entire field. It's like biology, it's like chemistry. So it's very difficult to say, well, here's one textbook that summarizes an entire field. If you're interested in model-based clustering, for example, one of my colleagues, Professor Brendan Murphy, has just written a really excellent text on that. But it is a little like asking, well, is there a good textbook for biology? Because it's a huge and diverse field, depending on the data type or the context, and so on.
And along those lines, here's an interesting one. Is statistics the same as data science?
So really good question. Statistics has been around for hundreds of years, and we've always been the science of data. In the sort of the data science phenomenon that we're part of, I think at present, statistics plays a key and central role in that. To me, data science goes from everything from, the designing of how you're going to collect your data, to the collection of it, the storage and the data warehousing of it, the extraction of it, the analysis, presentation, the write-up. And that involves, huge numbers of different disciplines and contributions. The piece that statistics as a discipline plays in that entire spectrum is within the experimental design. So back at the very start, when you're thinking about how you collect your data, and then in that, and the middle piece when you're analyzing the data, and then again very much in that communication piece. How do we present our results? How do you take that story out of the data and communicate it? So we're a key and fundamental piece of that data science pipeline, and always have been, but absolutely in collaboration with many other disciplines.
Okay. Here's an interesting one. You talked about data collection. So is there a statistics for data that cannot be collected? That is data so large that you can only get one look at it.
This is, more and more, as the data evolves so quickly, even compared to when I started. The scale of the data that I work with now on a daily basis was unfathomable, even 10 years ago. So these are the types of things that, evolve. So a researcher comes and says, well, my data is so huge, I only get one look at it. How can you help me analyze that? And we have a look and then say, right, well, there is no tool to analyze that, but let's derive a method to do that. So off the top of my head, I don't know a method to do that. There may very well be one out there. But that's exactly what stimulates and pushes the boundaries of the field of statistics.
It's your next SFI grant application.
Yeah,
yeah, exactly. So here's one. So this is an interesting one, slightly controversial, but we'll give it a go. Statistical thinking has been conspicuously absent from major public big data efforts so far. For example, the White House Big Data Partners Workshop was criticized for having no statisticians involved. Have people woken up yet to the need for statisticians in data analysis?
Good question, and I'll give, bias is a thing we talk about a lot in statistics, so I'll give it a slightly but openly biased answer. We have to be involved where there's data. I spoke about that data science, sort of spectrum. The very first piece of that is collecting data, and that's, a module that we teach in experimental design, an entire area of research. And as data, just flows nowadays, it's there and it's vast and it's accessible and all of that. But if it's not collected or the process in which we acquire that data isn't thought through and embedded in the way we analyze that data, then what we get out at the end is somewhat meaningless. We have no rigor or sort of confidence in the resulting inference. So that's statistical thinking. It needs to be involved, not when the data are gathered and you come to statisticians and say, can you help me? Yeah. You need a statistician before you even think about designing the study, because that influences everything right the way through. And it's still as relevant today in the data science world as it was, 100 years ago, when experimental design was very much at the forefront of the boundaries of statistical research.
Yeah, a lot of questions coming in from you, Claire, around that kind of area of, uncertainty. You mentioned it there, the uncertainty around conclusions. So I'm going to try and ask one of them. So this is a really interesting one, but it kind of goes along the same lines about uncertainty around conclusion and making a decision afterwards. It's, why do people confuse causality with correlation? And how do you teach students to distinguish the two?
Very good question. That's again, another sort of a drum that statisticians constantly beat. Essentially we teach it in every module and every aspect of statistics is, observing a relationship is not, doesn't mean there's a direction in that. But again, causal statistics is a huge research area of statistics. There would be research groups across the world that focus purely on that. It goes back to the communication piece. I think such a key part of working with data and being statistically literate is getting that message across of uncertainty, or, this is what we observe, but, we're never certain. Data are concrete and on a hard drive, but they're totally uncertain. There's uncertainty in perhaps the way they were collected and in the sample from which they were collected. So the key piece is communicating that uncertainty, and that feeds into things then like worrying about causality and correlation. The direction of these things is hugely important, and establishing causality is a hugely difficult thing to do. And particularly when you have observational data, which is this kind of, data that just, accumulates and appears, which we're working with more and more these days. Establishing causality is a really difficult thing to do. But in terms of teaching it, there's hundreds of different sort of toy examples that we use, predominantly in those early year modules where we teach to try and, essentially our role is to try and train our students to be statistically literate, to be both not saying that correlation is causality, but also being aware that if they see something, not to be sort of fooled at thinking that the relationship they see is a causal one.
Yeah, there's a lot of questions around that even still coming in. So here's one, but I'm going to ask you two. Okay, so I'll do the first one first. Is it possible to determine the direction of the arrow of causality? If A and B are correlated, can you determine if A causes B or B causes A? And the second one is, are all models are wrong, but some are useful? Please comment. But I think if you've anything else to add, that'd be great. I just wanted to ask them.
So the first one, on which direction the arrow goes, that predominantly goes back to I'm going on and on about experimental design today. But if your experiment is set up, or the way you collect your data, experiments still is kind of connotations only with science, but this applies right across humanities and social sciences also. The way in which you collect your data can allow you to infer causality, and the analysis tools that you may use may allow you to infer the direction of that arrow. But if you haven't gone about collecting your data correctly, it's an extremely difficult thing to do, is to absolutely put that arrow in a certain direction. So again, to reiterate the point, bringing the statistician in on day -10, not when the data are collected, is key.
Okay.
And then to go to your comment on the all models are wrong, some are useful. It's actually, that's become a real, it's a well-used phrase. It's by a very famous statistician, George Box. But if you actually read the paper, which is in the Journal of the American Statistical Association, from which that's extracted, his phrase is actually, all models are wrong and the scientist must be alert to what is importantly wrong. So okay. I'd now replace the word scientist with a more broad spectrum of disciplines. But I think that's the piece that we always need to be conscious of. We know all models are wrong. Most models have some sort of assumptions. And it relates back to that piece on uncertainty. It's, getting your result, but then thinking about, right, well, what about those assumptions? What if one of those assumptions wasn't valid, how would things look? Or what is the uncertainty in this result based on what may be wrong in my assumptions? And then does that really matter in the context of the decision I'm trying to make, or the policy I'm trying to implement? Which of those assumptions being wrong is actually important?
Okay, and we're completely out of time, Claire, so I have one quick question to close, but I'm kind of summarizing two. You have developed a broad array of statistical methods inspired by interdisciplinary research problems. Which are you most proud of? And another one, what's your favorite story? So what's your I suppose, favorite story of statistics data, and which are you most proud of? You can probably combine that.
I think the key thing to point is that I haven't developed these in isolation, and predominantly they've been the work of my really excellent PhD students. So I might pick two different ones then, if that's okay. So one, I'll tag back to my former PhD student, Damien McParland, who's now a data scientist with a cybersecurity firm in Dublin. So just showing the diversity and applicability of statistics. But he developed an approach to clustering data when the data that are collected are of different types. And as part of that, he developed a software package that's now well utilized. And it's great to see that there and working. And Damien was a great experience. I suppose that's kind of the piece that is nice. Then a story that is nice is a collaboration with Professor Lorraine Brennan in UCD and a colleague, Dr. Sylvia D'Angelo, also in UCD, where Lorraine had a group in their research. They developed a feeding study and looked at the relationship of consumed quantities of apple with the biomarkers. But then our task was, okay, well, if you're given the levels of biomarkers, can we infer the actual quantity of apple inferred? So again, Sylvia is the credit. She developed what we call a Bayesian factor analysis model that allows us to do this inference. And she created, again, software packages and a web interface that allows a user come along and input their data and infer these apple quantities. So everything from cybersecurity there to apples. But again, most credit goes to the great researchers that I've had the luck to work with.
Oh, but under the wonderful guidance of you, Claire, it can't not be said. So we are completely out of time, Claire. I'm so sorry, and sincere apologies to all of you whose questions I didn't get to. I just wanted to take this opportunity to say a huge thank you to Claire for the most fascinating discussion today. Thanks so much, Claire.
Thanks for having me, Patricia. It's been great. Nice chatting.
Oh, it's lovely to have you. And you can sign up for our series at zoomforthought.ie. And this is the last one for the summer. And we'll see you all back in September for much more Zoom for Thought. Thank you so much, everyone. Take care. Bye.